welcome to the observation deck of the first space elevator of Class Atlas, the pinnacle of human engineering thought. If I haven't met some of you before, I am Alka, Professor of Systems Engineering at the Utah Institute of Cryogenics and Magnetohydrodynamics, and Division Vice President at the Golden Age Cable Group. We apologize for the extraordinary security measures you had to endure in order to attend this meeting. It is, after all, an extraordinary meeting, and we had no choice. From the moment you signed that NDA you kept asking about, you ceased to be here by privilege or invitation. You are here by obligation. You've been drafted. All of you have been vetted. A proven lifetime of brilliance, exceptional resilience under stress, selfless devotion to your craft. We did not choose this work for ourselves, but we are going to undertake it. Some of you have already guessed where this is going. It has been in our textbooks for centuries now. Tiamat, a remnant of a giant comet torn apart by Jupiter. Its orbit evolving chaotically with each perihelion passage due to asymmetric outgassing and recurrent fragmentation. 3 centuries ago, after thousands of observations from our probes, we were finally able to predict its fate. Little did we know the fate we calculated was our own. The last few decades have brought critical refinements. In 200 years, the largest surviving fragment of that comet and its accompanying swarm will settle into a resonance orbit, one that crosses our own. This is it. Upon hearing this, you now carry knowledge that, under top-level international agreement, will not be communicated to the planet for at least a century. It is the moment of your lives, beyond which there is no turning back. From this day, you are part of an extraordinary group. Infrastructure Resilience Committee, Program SURTRBIF. Other programs exist, but you will interact with them only on a need-to-know basis. It suffices to know that they work on problems adjacent to ours. If fortune favors us, our work will be remembered as ushering in the next generation of materials science. If fortune does not, we are the stopgap of humanity before the abyss. It is our duty to do all we can to ensure that the line does not end with us. I trust you appreciate that with the full gravity it deserves. Several programs attempted to model orbital deflection scenarios for Tiamat. None succeeded. The object is disintegrating too rapidly. Outgassing has introduced unpredictable non-gravitational perturbations. Every model fails before we can act. Those programs have been retired. Their talent has been reassigned to the next best option, identifying the largest fragments and pulverizing them. The best solution discovered so far is to dissect Tiamat into several components at the precise moment of maximum tidal stress, so that we confront multiple smaller threats instead of one planet killer. This effort has already begun. Thermonuclear devices are being prepared as we speak. Modeling indicates that the resulting debris fields will contain numerous bodies up to 1 kilometer in diameter. This is unavoidable. The probability of a direct impact event by the largest fragments remains low, but the residual swarm, composed of sub-kilometer blocks, presents an imminent and long-term threat. And what does that mean for us? Our beautiful planet is exceptionally vulnerable. Yet the nature of that vulnerability depends on where the fragments fall. The modeled impact distribution forms a broad band shifted toward the northern hemisphere, the hemisphere presently locked in ice. As you recall from your field studies, at this stage of the Gaia history, nearly 10% of the planet's surface, over 30% of the landmass, is buried beneath continental ice sheets several kilometers thick. Given the distribution we observe, there is effectively a 100% probability that at least one major fragment will strike those ice caps, probably several. Such an impact will inundate our world. 80% of the population today lives in coastal basins that will be devastated by tsunamis. 60% live in regions that will vanish beneath the waters released when the ice disintegrates. Sea level will rise by at least 50 meters, perhaps more depending on how fast the polar sheets collapse. The atmosphere will be loaded with vapor, ash, and nitric oxides. Expect acid rains and an impact winter climate. This is not a drill. This is not a worst-case scenario. It will happen. An even greater concern is geological. The internal structure of Gaia is complex. The crust we inhabit is a brittle skin over a convecting mantle. Beneath us, at this very moment, Atlas's foundation bores extend 20 kilometers down, mining and monitoring the geothermal gradient. Large impact at the wrong location could upset this equilibrium, awakening tectonic forces on a scale our simulations cannot yet model. Enjoy for a moment this view of Gaia, veiled by the auroral light that Atlas induces in her atmosphere. We do not have time for an apocalyptic tour. You are here because this group's mission is to enable the next civilization. Yes, I am not choosing my words lightly. You now live with the knowledge that our civilization is ending. What comes after depends on you. There are ways to preserve our knowledge, but not our industries, not most of ourselves. We are preparing archives on the Moon and Mars, but someone must one day return to retrieve them. Tens of millions live aboard the orbital platforms and the smaller tethered elevators, yet every one of those habitats is connected to Gaia by an umbilical cord of supply lines and superconductive cables. Even together, they cannot sustain civilization alone. Deep karst systems are being sealed and converted into shelters. Data and genetic archives are being dispersed across the solar system. And our role? We are Gaia's last attempt to hold on to the sky while the sky itself is falling. If Atlas survives, humanity retains its claim to the stars. Atlas will consist of 3 principal components, and it will be your task in the decades ahead to perfect each of them. First, the subterranean shelter, a cylinder 10 kilometers deep and 20 kilometers across. Within that space, we must house our most advanced computing systems designed to endure for centuries. The cryogenic biology group promises hibernation pods, true suspended animation. If they succeed, a fraction of our brightest will sleep through the deluge, preserving a fragment of continuity when the world reawakens. Second, the cooling and power infrastructure. The shelter cannot operate without immense heat removal. The expanded solar array of Atlas will deliver that power via the tether itself. Woven inside it are ribbons, a superconductive CNT composite, channeling current from orbit to surface with negligible loss. The energy delivered will equal roughly 1/3 of global human consumption today. Third, the habitation capsule, a vast structure spanning several decks. Within it lies the observation deck of Atlas, where you now sit, watching Gaia's curve through the aurora the tether induces in her upper atmosphere. Many have mocked its size, each deck larger than any maintenance crew could ever fully utilize. Now you know why. This station between surface and space will host hundreds of crew, scientists, and engineers, humanity's last bridge between Gaia and orbit. And yet, even if we succeed, we will only have bought time. Twice each year, Gaia will encounter the remnants of the shattered Tiamat. Every few thousand years, perhaps even more frequently, statistical inevitability dictates that such an encounter will bring catastrophic consequences. These crossing events we have named Sekhmet and Apophis, corresponding to whether the swarm approaches from the direction of the sun during the day or from the outer reaches of the solar system during the night. The distribution of fragments is neither uniform nor static. Confluences will occur in both time and space when the swarm forms dense clouds of debris precisely as we intersect its path. It is these density peak events that concern us most, due to the orders of magnitude higher likelihood of not just a single impact, but multiple closely spaced encounters, cumulatively posing a far greater threat to civilization's capacity for recovery. The swarm will cross Gaia's path again and again. The threat will endure for no less than 20,000 years, the limit of our present modeling precision. Our simulations indicate a major density peak approximately every 3 millennia. A celestial clockwork of destruction that will dictate Gaia's fate until we find a permanent solution or join the lost. We cannot promise survival. We can promise only that if Atlas endures, so does the possibility of memory, and with memory, rebirth. That is why you are here. Welcome to the Infrastructure Resilience Committee, Program SURTR-BIF. Your work begins now. Hello everyone, it's Alka again. We did our best. You are living proof of that. It's your turn.